Are you being able to see my screen? Yes.
Yes, I see it.
Okay, so this is our Google Classroom. We put that picture because we were living for coronavirus, but okay. In our classwork, in our Google Classroom, it looks like this. So this is the end. This is remote learning. These are the quizzes that we do. The grading structure, they have to do the labs, but 30% of their grade is based on quizzes. So the quiz is asking them how to do something that they already did in a lab.
Mm-hmm.
So these are the homeworks and these are the Python labs. So I think this lab doesn't have the Pokemon one because that one is after we left. Let me try to find Serena Williams in here.
Oh. Is there one that's like the Pokemon? I guess. No.
Yes. I have to. This is a good example of. Yeah, I think this is a good example. So look, for example, this is one of their typical assignments. So there is a rubric of what we're looking for in the code, and it shows them what we are grading. So for example, this is what I was telling you, like they have to ask for help, and this is in the autograder. You need to have one help documented in your code, errors from the autograder. Okay, and this is what the autograder is looking for. Do you have, did you test 3 times your code, within your code? Do you have a loop? Do you have a function that has one input parameter? Okay, the lab will look, this is the PowerPoint. So this is the presentation that shows the content, and this is the video, which is basically, us narrating the PowerPoint. So.
Hello, everybody. In this video, we're going to look at string manipulation. All right, let's get going. So this first example right here is a review. And in this review, I iterate over list.
There we go. Okay. So that's the video, and that's the presentation. And basically, it shows the syntax. And then the lab looks something like this. This is finally the lab. So there is an algorithm that says that if a movie has in the title all of the letters of Samuel L. Jackson, or 4 letters out of Samuel L. Jackson, is going to be a good movie. And if it has less, it's going to be a mediocre movie. And if it doesn't have any letter in Samuel L. Jackson, it's going to be a bad movie. So in here, we explain that. Like it's kind of like a funny something just to
yeah,
make them laugh, hopefully. Nothing, the privilege, okay. And then these are the instructions. So have discovered that if a movie, it is called the Samuel L. Jackson algorithm. It has been described, okay. Create a function called Samuel L. Jackson, where the input parameters is a single word. It returns good, bad, or maybe. And in here, in the algorithm, if the movie has 0 or 1 letter from the Samuel L, it is rated as bad. If it has 2 letters, it is rated as maybe. So as you can see, this labs tells them what the function has to return. It tells them that they need to have a function called Samuel L. Jackson, and it tells them that they need to have the one single input parameter. And it tells them how the algorithm has to work. So what the autograder is looking is that they have a function called Samuel L. Jackson that it takes one parameter and it's going to give it multiple inputs and it has to return only these things. And that's it. And how do we check that it works? Well, if we know that the algorithm has to work. So we have some movies and depending on what that movie is, we know that it should be good, bad, or maybe. And that's how the algorithm, that's how the autograder works.
Yeah, thanks. This is helpful.
This is a typical lab, yeah. And I'll find the Pokemon one and send it your way. I have the answer, I think. So look, let me see. I think I was working on it. That's why I remember it so good. This is another project. This is the Rocksays. Would you like to see the autograder that we have?
That's okay. Actually, I would like to go back and talk a little bit more about the creativity in Pokemon, and then I have a few more questions at the end.
Okay.
I think that will be more helpful than looking at the autograder for this. But thank you for sharing all of that with me.
Yes.
So you were saying that students do get more creative with the Pokemon task. Yes?
Yes.
And so how long is that project? And like, so how is it that students are able to be creative within that lab? What are the different ways?
Well, for example, the Pokemon lab, it gets them to give some damage to some of the Pokemon depending on what types they're interacting. So, for example, there is freedom for them to decide how much one Pokemon can damage the other one. So that is something that they can modify within the program. We ask them to, for example, do a list of Pokemon of one type and then make each element in that list attack another one. So they can write their own Pokemon. So some students say, okay, the real Pokemon names, and some students is like, okay, Mr. Martinez is going to be a Pokemon and he's going to fight Dr. Wu. And okay, Mr. Martinez is a type grass and Dr. Wu is a type water. And so it gives them a little bit of creativity into how they do the details on their program. Whereas, for example, Samuel L. Jackson, the only freedom that they really have is to test it with movies. So at some point you see them, oh, let me check the Samuel L. Jackson algorithm with this movie, or that, oh, it works, or it doesn't work. So I think the Pokemon lets them be a little bit more creative on how they finish it.
Yeah. And do students have difficulty with that Pokemon task?
It is, because the lab is hard, like the concept of the objects, and because that's one of the latest projects, so it incorporates a lot of what they have learned before. So sometimes it works, but it might not be doing what the algorithm should be doing. So, and it's not passing the autograder, and it's a program that is maybe 120 lines long. And I think that the mistake will be to tell the student, okay, send me your code over email and I'll take a look at it and I'll tell you, you just have to fix this. I think for that project, it's better if we can teach them what they could use to troubleshoot. Okay, like, how do you know what's the function that is failing? Is the program failing because the first step is wrong? No. Okay, then let's find a way to trip the second step in the program, and so on. Yeah.
Right. And since it's a game, do students like play each other's games or share what they did with each other?
No. In this game, just the program itself is playing itself. We ask them, okay, have all of this, make 5 water Pokemons and have them 5 fire Pokemon, and it should print. Pokemon 1 is attacking Pokemon 2 with 300. Okay, Pokemon 2 final health is 23.
Okay. But do they share ideas about because if they're all producing slightly different solutions, do they talk to each other or share about what they did?
They do,